Welcome back to the Crest series, and now we need some dust. So for this next part, I'm going to show you what I did in EmberGen to generate some dust. It's some really cool software for doing real-time fluid simulations, and I think that you should check it out if you're interested. If you would like to follow along with the same sequence that I'm using, that is available on Patreon. Otherwise, I highly recommend just grabbing a trial of EmberGen and having some fun and making your own dust sequences. So we're going to be loading in a VDB sequence into a vray volume grid. We already went over that in a previous video, but we're going to be doing that again. And I would like to remind you that the scale of the scene is not correct, which is something that I mentioned in a previous video. Embarrassing, yes, but we can still make it work. All right, let's get started. All right, so now we're going to be deviating a little bit from the original lecture material. So in the original series that I gave to my class, I ramble on for about 5 minutes about Phoenix FD, and I don't think that's really necessary for us to do here. But really quickly, I was intending to use Phoenix FD for this project. So Phoenix FD is a simulation software for liquid simulations or smoke and fire simulations, much like EmberGen, what I'm going to show you. The differences are that it's all done inside of Maya or 3ds Max, and you can have unlimited interactions with geometry. It can do a better simulation in terms of quality or accuracy than EmberGen can. It's also better at doing simulations over a lot larger area because it can dynamically resize its grid and not have to have some massive area or massive voxel density to be able to show a simulation over a large area. But that comes at the cost of really long simulation times, huge amounts of data. For example, I've had simulations that have been around the 300 frame mark that have been over a terabyte, and it's quite complicated to use in my opinion. So for example, for this project, the lowest quality simulation that I thought was usable using just some primitive geometry as a collision object was over 25 gigabytes, and it took a couple hours to simulate. Not really something that I could easily deliver to my class and say, hey guys, go and do this, or download this sequence. It's huge, right? So what I decided to use was EmberGen, which is what I'm going to be showing now. So the major difference between EmberGen and Phoenix FD is that it is real time. So with Phoenix, because it's not real time and there are so many different settings, unless you specifically know what every setting does, in order to find out how it interacts with your simulation and how it changes your simulation. For example, let's say that I wanted to increase the amount of flames. Well, there's quite a few settings that do that. So in Phoenix, we would have to go and then change like the intensity or the heat of the flame or whatever, and then try one setting, change that, resim it, render it, and then see what that one thing did. You never want to be changing multiple settings at a time when you output, otherwise there's too many variables to figure out what exactly was changed. But in EmberGen, let's say I wanted to increase the flames, go over to simulation, I could go down to combustion, and then I could just increase the flame intensity. Maybe that's all you wanted to do. Or maybe you wanted to change the temperature. We could go to the emitter and then increase the temperature here, and maybe that would do it. Or maybe we don't really want any fire at all, and we just want to decrease the temperature, so we just get smoke. And you can see in real time what changing these settings does. And you can also, to some extent, as it's playing, increase them, and you might even be able to simulate what animating those values would be too. So that's just a quick look at why that's more advantageous, because just doing those simple things inside of Phoenix would take a long time to be able to make the change, simulate it, render it, and then compare it. Whereas with EmberGen, we just made that comparison in a few seconds. So EmberGen comes with a lot of different presets. For example, we could take a look at this fire tornadoes and then just see what that looks like. It's kind of cool there. And it's very quick just to kind of break down what they did or play around with it. Like maybe I want to lower the burst, have that kind of go away, or increase the burst, see what that does, or time between bursts, things like that. You can kind of interact with the look quite quickly. If you want more fuel, whoa, less fuel, just smoke, you know? So it just, it's really cool to play around with it and see what they did. Quite a few of these. If you're not really interested in playing around with EmberGen itself right now, but you just want to get a feel for the types of VDBs and the quality of the VDBs that it can export, they do have quite a lot. If you go to downloads, free VDB examples, and there's a lot of free ones that you can play around with. I showed in one of the previous lectures these clouds here. I didn't actually download them. It just shows you where you can get them. But you can see the quality, and you can get quite detailed stuff with them too. And then you can break these down and then see what they did to make it. It's not just the VDB, it's the .ember file as well. So EmberGen is relatively new, but the results are really good for what it is. These tend to be much smaller scale simulations, like a little bit of smoke, a little fire, some explosion, some dust, like I'm going to show you. Not as useful for multiple geometric interactions. Like you can't have a lot of different meshes interacting. I think at least back 6 months ago, you could only use one object. I don't know if they've changed that since. But it's also really good at generating flipbooks. So flipbooks are much like sprites, but instead of having just a single image, it's basically a much larger image with lots of different smaller images on it. And then the way the flipbook works is for every frame of the animation of the sprite, it would load in another frame of the sequence. For longer sequences, you can use what is called a motion vector pass as well. So that will try to blend in the motion. So software like Unreal, for example, will interpolate between frames and smooth out that motion. So that allows you to extend the animation without having excessive amounts of sprite images, basically. So most of the times in games, if you see an elaborate explosion or something that's quite detailed, it's not actually in 3D. It's just a sequence running on a plane. Nothing wrong with that necessarily, and you can use that for effects as well. But in our case, we do need a 3D dust cloud, essentially, because it's going to be interacting with the camera. So instead of using flipbooks, we'll be using VDB sequences, which are actual volume grids. So EmberGen's been used by lots of different companies, but it's still technically in beta, I believe. But if you are interested, I would go to JengaEffects.com, go all the way down to the bottom, and then sign up for a demo. I think it only lasts for 2 weeks, but as far as I'm aware, it's fully functional. So you can see if it would be viable to use for the kind of work that you would like to do. I do recommend it. It's not that expensive when you compare it to software like Phoenix, and they have a good rent-to-own system. And apparently they also have a student license now. So I didn't see that before. Maybe it's relatively new. So if you guys are students, check this out. All right, so finally, in EmberGen. So when you first launch it, it's going to start playing right away. I'm going to stop that. And there is one concern about EmberGen, and that is the strain that it can put on your GPU. So I have some software called GPU-Z, which is just a monitoring software. It's free, so I would recommend that you use some kind of monitoring software. I have an RTX 3090, which is a high-end card for sure, but I have the Founders Edition version, and the fans don't directly cover the VRAM. So my concern is always how hot is my memory temperature? Right now it's only at 60 degrees Celsius. That's not that hot at all, but this will very, very quickly jump up when we start doing a larger simulation or exporting the VDBs. And if this gets over like 104 Celsius, that's something to be concerned about. And I have had the computer shut down a few times using EmberGen before, so just be mindful of it. But there is something that you can use to mitigate this problem. You go up to Settings, Preferences, make sure you have a frame limiter set. I have mine at 60, but you may even want to go lower than that. I also go to the viewport quality. I just set this to low because we're not going to be rendering in it. We just need to basically see if the shape is correct and the way that the smoke or simulation is basically interacting. If that looks pretty good, fine. Like we don't really need to have high quality for this, okay? Right, so the next thing is, let's go over to our node graph. So everything in EmberGen is node-based. If you click and drag the middle mouse button, this is how you pan, and then you can just zoom in and out with the mouse wheel. So if you go to the sky box over here, go to sky, atmosphere, and I'm gonna say none. I think this is gonna be easier to see our smoke because it's gonna be pretty thin smoke. So we just wanna be able to make sure we can see it a little bit better. Next on the ground, I don't think the checkerboard is particularly easy to see, so I'm going to say noise, or you could say uniform color if you just want it all gray. I like the noise one, so I'm going to leave it at that. Another thing, if you hold down the control key, you can zoom in and out on this. I have this set to, I believe I made my sequence for the original one 500 frames, but if you bring up a cross multiplier up here, so we're going to do frame rate over here and then the length over here. So Maya is using 24 FPS, EmberGen is using 60 FPS. We know that the length of our animation is 200 frames. I do actually extend that out later on, but that means that at 60 FPS, we would need 500 frames to fit in the same amount of time. Now, we could go and change EmberGen so it's not rendering as many frames. However, the VDBs at this export are actually quite small, and if you have more frames than you need, it's much easier to retime your smoke sim, and which we do end up doing. And then when I release this again for Patreon, I did tweak the settings. I extended it an extra 100 frames, so I didn't have to go back to EmberGen and re-render stuff. I could just tweak the timings of this basically. And if you want to kind of fade out your smoke at the end, having more frames is generally better, but that's completely up to you. And you don't need to use these calculators if you don't want to, but a little bit of calculation there will just save you a little bit of headache maybe later on. Anyway, frequently what I'm going to be clicking on is spacebar to play or stop. You can also just click this, but every time we make a setting, it's just going to start it up again after it's finished. But this is not really going to finish. This is going to go on for quite a while. So if we want to reset it, we can either click this little button here, or we can just click R. So if I play it, I can click R, and then it will just start over again. Okay, so that's what we're going to be using here. All right, so the next thing I want to do is go over to the shape over here. I want to change the type to a cylinder, just a regular cylinder. And then I'm going to make this pretty short. I'm going to make that 0.1 meters. And if we play this, we can see that there's still fire there. So we really don't want any fire at all. So if we go to emitter, we can go down to emission and then just say no emission. So that will completely get rid of the fire there. Another thing that we could do is set the temperature so the temperature is lower. I want to use something around 300 Kelvin. So that will get rid of the fire as well. But if you just don't want it to do any calculations on it, I'm assuming that's probably a little bit easier if you never want to see fire. I'm just going to say no emission on that. The next thing we need to do is change our smoke rate. So what I need to do now, let me pause this, move our slider back to start at 0, and we need to start animating some values. So what we can do to animate it is just click on this little dot here. That will set a keyframe. Always make the keyframe before you make the change if you want to keyframe that value. So I just left that at the default. At the beginning, I'm going to say that is 0% per second. And then we could go forward. I think what I did is around 140 frames, but this is completely arbitrary. It just depends on your sequence. And then I went all the way up to 50% per second. We can see what that does. You can see that it's just less smoke at the beginning, and then it will pop up. I think another thing that would be useful is to not see our cylinder in there. And the way you do that is if you go down to visuals, show emitter, turn that off. And now this is going to be a little bit easier to tell. We can also change the color of our smoke. And I think that will be useful to be able to see this more easily. If we go down to shading and then scroll all the way down here to smoke color. You could even make this like a really bright just so you can see it better. I'm going to do something that's a little bit more, probably more saturated than it really would be, but it would just help us see it a little bit better. Okay. The idea is we want the engines, imagine like the Razor Crest is landing and we want the force field or gravity thing or whatever it is, the engine, the thrusters or whatever you're trying to do is probably something pushing it down. So what I used on this is basically on the shape primitive at frame 0, I animated the radius. So on the radius, I set a keyframe there, and the radius at the very beginning at frame 0 is going to be 0. And then we're going to go all the way over to around 300 or so, and then increase the radius to 5. Now if we play that again, we can see not a lot happens at the beginning, but then it's going to get more and more and more. Still does not really look like the shape that we want though. So next we're going to add a force line. So I'm going to right click over here and just type in force, and then you can get the force line here. And we're going to attach the force line to forces of the emitter. So on the force line, there is what's called the push strength and the repel strength. So at frame 0 on the repel strength, we're going to say 0. Go forward to maybe around that same frame here, 140. And then on the repel strength, we can say 50. So now if we go back and play that again, you can see now the smoke is coming outward. We're also running into the bounds here, so we need to change that in a moment. Actually, we could change that now. If you click B, you'll show your bounds, and we can see that is nowhere near big enough for what we need. So if we go to simulation, we have to increase our voxel count. Type in 256, and we could leave the height pretty low, or we could just say everything's 256 for now. Apply new resolution. You can see that's a lot larger. So now if we play that again, not a lot happens at the beginning as it's coming in, and then it gets pushed out quite a lot. And we're still hitting the bounds, but I don't really want to change the size right now even more. But you can get you're beginning to get those nice little ripples, which looks pretty cool. Okay. Now we're not really going to be at an angle where we're going to see that for our shot, but if you were looking to see more of that, then you can play around with how that looks. Also, as I edit this looks super laggy. I can assure you that EmberGen is not usually this laggy. It's just the fact that I was recording at 30 FPS instead of 60, just because everything else in this lecture series was 30. And now you can see it's super choppy. So you should be able to get better performance out of it if you download this yourself. Okay, next. I'm going to go all the way back to 140, back to the force line, and then we're going to increase the push strength. So at the very beginning, I want to set a keyframe here, and the push strength is going to be negative. I think I said 95 on the last one. So there's constantly going to be a force pushing down, but over time, we want to lower that. So we can go all the way to frame 500, and then I'm going to lower the push strength to 0. And we can also lower the repel strength as well. So I think I said 5 on this one. All right, so for right now, this is not looking as good. We just basically have a ring pushed out, but we need to change some other settings first. I'm going to go down to simulation, and we're just going to scroll down until we get to the combustion section. And for the combustion, I want this to generate 100% smoke. For the smoke dissipation, I want to change that to 0. So now we're getting a little bit more smoke there. And keep in mind that a lot of that is when the Razor Crest is coming in. So if we zoom out, we're now getting a nicer cloud of dust. I'm sure that there's going to be a lot of other people out there that's going to make a more effective smoke sim than I'm going to show you, but I'm just showing you what I did. For the vorticity, I am going to check pre-advection vorticity, and I'm going to increase the vorticity intensity to 60%. You can also change the large scale one. So if you want more like larger plumes, like clouds of dust within it to get a lot larger, you can increase that. I'm just going to leave that right now at 0% for right now. Okay, so scroll down even more. Right down here, there's an option called blocking Z ground. So we're going to enable that as well. That means that it's not going to go lower than where the emitter is. That. And now we're going to get more of a shape that is what we had before. Okay. We're still getting those rings getting pushed out. All right, next is wind direction. I'm going to add just a little bit of wind, and I'm just going to change the direction. This is just what I did before. I just found these settings to be nice. I'm going to increase just a little bit of wind, and I also want to add just a little bit of wind chaos too, because I think that will look pretty cool. And another thing that I've realized is as we progress through this, I do want to reduce the amount of smoke that's being emitted because there's a lot of smoke that keeps getting kicked up. But as soon as the Razor Crest lands, I want the engines or whatever field is pushing the dust down to get less and less and less because it is no longer firing downwards. So what I'll do on that one, I'll go all the way to, let's say, maybe 450, 440. And then for the smoke rate, I'll set that back down to 0, reset that, and then play it again. So now we're getting some nicer dust like that. And this is pretty thin and wispy, but now you can see that the wind is having an effect on it. Looks kind of cool. And then we can go down to turbulence. I did add some turbulence on top of everything else. I said something like 1% advection, 20% for the smoke turbulence. Kind of see adding just a little bit more variation there. And then for the size, let's increase the size of that. So now it's a little bit more chaotic. And if you wanted more smoke, like maybe we wanted to have that smoke still kicking up quite a lot until towards the end, we could just add another keyframe in there, so it's still going to kick up more smoke as it comes down. And then it will die off like that. The masks are pretty useful if you had a ton of smoke and you just wanted to reduce how much smoke was being seen. You can play around with these, but our smoke is fading off fairly quickly, so I don't think that's going to be necessary for us. If you want the smoke not to go up so high, you want it to keep falling down. If you go down to force, you can decrease the buoyancy or you could increase the weight. If I wanted this to be heavier, I could increase the weight of the smoke there, and you can see now it doesn't go up as high. It stays lower. Or we could just reduce the buoyancy. You can see both of those working in tandem, and that's going to be a lot closer to the ground. And then by the end of it, it's going to slowly it still moves because we have that wind and it still fades out. I think what I did on mine, I left that at 50 and then I increased the smoke weight just a bit. So we still want some of that smoke to get kicked up pretty high because it normally would. We could even increase our buoyancy quite a lot and then just increase the weight of it. We still get some that creeps up, but then the whole thing is not going to keep creeping up towards the end. I don't know. These are similar settings. Looking back at what I did, I'm seeing slightly different results anyway, so just play around with those values. So in terms of the GPU memory, if I pull this over, we're now hitting 100 degrees Celsius. It's dropping down just a little bit. I am also recording, and I do have another instance of EmberGen open, but it's paused. But just be mindful of your memory temperature, because if it gets a lot hotter than this, it could potentially be damaging to the hardware. Technically, it would have to go quite a bit higher than this, like into the hundreds, like 108 or 110 or something. I can't remember what the actual specs are from NVIDIA, but it is getting quite hot, right? The load is also, at 99%. Memory is not actually using that much memory. So yes, I have a 3090 with 24 gigs, which is nice, but not really necessary for what we're doing. We're not really using all that much. All right, so let's say that we're happy with this smoke. If you zoom out and we look over here, this is going to look pretty thin and wispy. Now, when we save this out as a VDB sequence, we can increase the intensity by increasing the opacity or the thickness of the smoke. So what you see inside of EmberGen is not one-to-one of what is going to be rendered out in vray, because vray will have its own interpretation of what the volume looks like in terms of the thickness or the color or the translucency or whatever material you decide to use for it. The shape and the overall motion is going to be more or less the same, but it's not exactly one-to-one with what you see in EmberGen. So also keep in mind that the camera is going to be really, really close here. It's going to be like right here. So if we want to see what that looks like, we're going to see dust getting kicked up, and then it's going to come towards the camera. We're going to see dust being pushed towards the camera this way too. If you want even more detail than this, you can go to the simulation size, and you can increase the voxel size. That's fine. This is going to increase the amount of memory that is going to be required for it. You can also use upscaling. So what I did on mine, I ended up going to X2, I believe, or maybe even X3. If you apply the new resolution, now this is probably going to be quite slow. You can see it's chugging here. It's nowhere near as fast as it was before. But as the smoke comes out, you should see a bit finer detail. So it's a little bit finer than it was before. You can still see those ripples. If you don't want yours to fade off as quickly, I would just go to the smoke rate and just still have it kick up some smoke towards the end. Again, this is more or less what I did on mine, but I certainly think mine could be better and more detailed. And at the end, we will end up using the VDB as like a copy. We'll have like 2 versions of it, slightly offset. And that's what I ended up using, just to add a little bit more detail. You can also do things like in post, trying to add a little bit of a fractal pattern on top of it. Quite tricky. You could blend this with some smoke elements of like actual smoke too. That's a technique that I've used before with really good effect to get some extra detail in there. And then of course, to get a lot of detail, it's the vorticity that's going to probably get you probably what you want there. So if I wanted to add even more detail to like the smoke clouds getting kicked up, you can increase the vorticity intensity and you'll get a lot smaller, noisier looking smoke. So that may or may not be what you want, because it's actually quite noisy back there, but it will make this pattern more detailed. So you may want several versions of this. You might have like a large scale version and then a small scale version, and then you could blend the two or have both of them running at the same time. That's up to you. All right, so that went on a little bit long, but hopefully that gives you an idea of how to use it. But then we need to export our VDB sequence. We're going to go to volume, drag out VDB, export VDB. You just choose a file path of where you would like to go. So I have one already set up here, and you would just give it a prefix and a version number, and then it will add in frame numbers for you. Honestly, these settings are pretty much good to go. Number of frames that you would want, I said 500 for something like this. Frame stride would be just 1, so it's just drawing every single frame. For the export, we're not doing anything with temperature or fuel, so we can leave those unchecked. For export velocity though, this is useful for motion blur, so we would want to have that enabled, and we also want to use the compression. In Maya, the coordinate system is not Z-up, it would be Y-up. Not really sure what the right or left-handed means. I'm just gonna leave that on right-handed. And the unit length is in centimeters. So did mess up the scale there, which I'll probably go over in a bit, but centimeters is fine. Floor 0 is fine too, and we should be good to go. So once you have a file path set, let me just make one quickly here. Dust version 5, and then I would just say export now. And when you click export, it's going to start at the beginning and then go all the way through. Now, this can take quite a long time to do, but if you increase the resolution, like you increase the upscaling even more, this could take over an hour or more. So it really just depends on your hardware. I think this number is not quite accurate. I think it will take longer than this. But for smaller scale simulations or lower detailed ones, it doesn't take an excessive amount of time. It's still much, much faster than doing this with Phoenix. Okay, right, so once that is done, you will then have a VDB sequence. If you're interested in using the same sequence that I used, you can find that on Patreon. All right, so now we're going to go back to the original lecture, and then we'll be going back to Maya. So this dust is slightly different, but the principles are the same. So the scale of this is a little bit off because we never actually scaled our scene properly in Maya. Like if we go back to that really fast, this is in centimeters. And if we grabbed just a cube, move a cube over, that's like one cubic centimeter. So we did not scale this right. And I looked this up. The Razor Crest is supposed to be like 26.5 meters. So that's way bigger, right? It's like 100 times bigger than our scene is. So when I was setting up the Phoenix sim, you do need to do that at scale, but Phoenix allows you to have like a scale multiplier. Like let's say your scene is not to scale, but you can't change it, or it's just too cumbersome to change, kind of like this. You can still simulate as if it was, real world scale. Now for something like this, we're not actually going to have the proper interaction of the Razor Crest falling down and actually pushing that dust away, but we can get something that looks pretty good. I think this is going to look fairly decent, and the camera's going to be pretty close to it, right? But it's going to be looking up. Let me reset this here. The camera's going to be looking up, and we're probably not even going to see that much detail in it. We just need some kind of a cloud of stuff. This is way too strong. And we'd also like to have a little bit of graininess in there, just like this actual like sand or dust or dirt or whatever it is being kicked up. And then we also need to probably play around with some kind of debris particle system, which we're not going to do in EmberGen. This is just for doing like smoke or fluid stuff, but we could do something like that in Maya. So anyway, you can set all of this up to render like a flipbook or just a straight up image, or you could export a VDB sequence. Then you just give it a location, an output location, then you say export now, and then it runs through it. And what you end up with is a sequence of 500 VDB files, and the largest file here is less than 10 megabytes, whereas with Phoenix FT 2-3 seconds in, we're already at like 100 or 200 megabytes per frame. So there's a lot more information that Phoenix generates, and we don't need it. So this is why this is such an ideal solution. Okay, so that's EmberGen. I don't actually need to save this. So what do we actually do with it? That's the next part. So most renderers have some kind of VDB import function, and the same is true with vray. So we've already done this with the clouds. So you just go up to vray volume grid. Then for the volume grid, you go into your input, and then for the preview and render path, browse, and then you would just go and find that VDB sequence. So this starts at frame 0. Maya starts at frame 1. So just bear that in mind. So we should end at 499, but I don't know why Maya starts at 1. That's kind of awkward, but we've already kind of animated this way. So usually we set that to 0, but whatever. Forgot in this case. And this is going to come in, it's going to be way too big because, as I said, we never made this to scale. But no matter, we can just simply scale this down. And this is going to come in on the last frame, I believe. So basically, we just want to push this. So it's just about going through the floor like that. And then we want it so as if the Razor Crest could actually land, somewhere in the middle there. Now, the exact scale of this is up to you. I would do something like this. You could do it a little bit bigger. You could do it a little bit smaller. If you wanted it to be probably more realistic, it would be bigger. But the whole point of this is I want to see detail through the camera. And if we look at the camera, you're just not even going to be able to see anything. It's through the viewport. It's just way too crowded. I can show you quickly how you can change that. We want to make sure though that goes through the floor. It's not floating up, something more like that. So if this gets really laggy for you, which it probably does, because if you try to step through this, if you scrub, like it might actually go pretty quickly. But if it doesn't end up going quickly for you, you can go down to preview. You can just say don't preview, so it will never preview it and you'll never see it in the viewport. You probably do want something in the viewport. Or you can do detail reduction, so you could just say like 2 and kind of see it reduced that a little bit, or 3 or 5 or 10, and that's way smaller. So it's going to be a lot easier to view if you want to see something. But if you're trying to look through this view, it's just in the way and it's annoying. There's also the option to use what is called the GPU preview, which is this right here. And this gives you more of an actual cloud, which might be more useful to you depending on what you want. Personally, I don't like that. I think it obscures too much. And I think for the most part, I actually don't want to even see that unless it's selected. So I'll say only if selected, then I can click off, and then we can pan around the viewport. We can see everything. And if I want to see it, all I have to do is make sure I click on it, and then it pops into view. I'm going to call this volume grid dust VDB. And then let's see what this looks like in the viewport. And I'm going to actually render from here first, just so it's a little bit more clear. And for this, because we're using a different camera, you want to make sure you go to your camera, attributes, vray, make sure you have a physical camera set. Should also be visible down here. Otherwise, it's going to be completely overexposed and way too bright. Right, so that smoke comes in and it is, and I keep saying smoke, it's dust, but most simulators do either like water-based stuff or smoke-based, and dust reacts more like smoke. Actually, all fluid dynamics, whether it's in the air or in water, kind of react in the same way, but There's, I guess, a lot more involved for liquids because you need like bubbles and splashes, so they're usually separated. All right, so if we want to make this not so dark, select our volume grid, go down to rendering, which is right here. And then there's a few options for the color and opacity like we did before. For the opacity, we're going to leave that color constant. For the color, let's do something that's a little bit brighter. You probably need to stop IPR and then update it manually to see a change. That's very, very saturated, very red. I don't want it to be that red. Desaturate that a little bit. That looks a little bit better. Maybe it's a little bit too dark. We might just brighten that up a bit. Something more like that is more in line with what I'm going for. It looks a little bit too pinkish right now, but we can change that when we get a little bit closer. Also, dust really depends on, you know, how, the sediment. Like you could have sand, you could have just dirt, and then sand has lots of different shades depending on the composition of the minerals, and same thing with dirt as well. So you could have what appears to be, you know, like a really dark like a dark dirt or gravel, but then the dust that gets kicked up is very light gray, or it could be very sandy colored or whatever. So it's up to you what you decide, but we'll try to come up with something that blends in with the environment. But right now it's a little bit early to start really tweaking this color, although we could just take the hue out a little bit, take that red hue out a little bit, stop the IPR, restart it, and that should hopefully just, you know, that's way too much green now. We need to use very subtle controls here. We need to move these very subtly to be able to change this. But this is something that we can control in post later. Having like a closer result in camera is always a good idea. Okay. I also think it's a bit thick. So what we need to do is go down to the smoke opacity. We'll just halve that number. So we'll do 0.25. Again, stop the IPR, start it up again. And then we'll just see what happens with that. Okay, so that's how you load in the VDBs. All right, so now that we've seen how the dust renders, we actually need to figure out how to time it. So in EmberGen, this was set to 60 frames per second, and we outputted 500 frames. But in Maya, we're using 24 frames per second, and our shot is 200 frames. So 200 frames at 24 FPS is going to be the same amount of time as 500 frames at 60 FPS. But when we load in that VDB sequence and you step through this, you can see that every time that we step forward, we're just incrementing one frame of that VDB sequence. It's going to take one frame, and whatever frame you're on, that's going to be the frame that it starts on. So there's two things here. Because Maya starts at frame 1 by default instead of 0, it's going to start one frame into the sequence, and at the very end here, it's only going to be on frame 200. So if we want to play back that entire sequence as it was in EmberGen, we want to change your playback mode to cache index. If you wanted it to loop over and over again, you would do loop, but we're going to do cache index. And at frame 1, we would say, all right, it's actually going to be starting on frame 0 for that VDB sequence, so we set a key. And at frame 200, we would say 499. So that will play the entire sequence. And every time we step forward now, we're going to be on a higher and higher frame. Now, if we go into the graph editor, the animation graph editor, by default, Maya will also ease in your keyframes. Well, that would not be what we wanted if we wanted it to look exactly as it was. We would want to linearize those tangents. And then we would be seeing the correct interpolation. Now, with that said, you might actually want to tweak this, because if we go to the very end here, like at frame 200, you can already see from the viewport that a lot of that smoke has dissipated. And if we render this, you can see that, yep, most of that smoke, or dust rather, is gone. So what we probably want is a little bit more lingering dust. And at the very beginning, we're not going to see any of this because the camera is aimed up and the ship is so high. So really, we could delay the smoke just so we get more of it visible when the ground is visible, essentially. Okay? So this is a little bit up to you, but what I'm going to do is, first of all, I'm going to ease this in. So I want to ease this in. I can select this keyframe and then do this button right here, which is plateau tangents. If I wanted to create this myself and add a new custom curve to this, if you try to pull out this tangent, you can't do that. So if you go up to curves, weighted tangents, this allows you to pull this out, and you can make it a lot slower at the beginning, and then it could speed up, midway through the shot. If you want to set that as default, you can also go to curves, default tangent, weighted tangents. I prefer this, and I think it's better to have weighted tangents. Gives you a lot more control. And likewise, you could ease out the end, or you could just say, hey, you know what? I want this to be a little bit slower, because I want it to start slower, but then I don't want it to speed up too fast so the smoke looks ridiculously fast. I could just say, all right, let's do something like 248 frames, so we're just delaying everything by 2 seconds. And we'll never actually reach the end there, which is fine. And we can just pull that up if we wanted to, or we could just do like a regular ease like that, or you could just say, just keep it linear. So it's up to you. So we actually need to see what this looks like in camera first anyway. So we will probably be adjusting that, but just keep that in mind. So some other things, you might want to scale this down even more. You might want to scale it up a little bit. Just depends on exactly where your camera is. But if we just go to our main camera view and then just have another look at this, we can see that this dust is looking pretty good. I think that's the right amount of dust. But again, we really need to see how this looks in motion because it might be going too fast or too slow or whatever. All right, so that's how you load in the VDBs, because that's really going to be an important part of the compositing. So make sure you get that in there. All right, guys, thanks for watching. If you have any questions about EmberGen or anything else that we've done so far, please just leave me a comment or join the Discord server and ask me there. Otherwise, I'll see you guys in the next video.